Coco's bananas. This is a tricky problem. I wrote out some long comments here, but don't worry. Here's a simpler overview of it. Basically, this problem, we are giving two arguments, piles and h, or hours the guard is gone. So we're going to have to use those. The first one, piles, is quantity, and the second one, hours or h, guard is gone, is time. So we're going to use four different variables here to calculate a rate at which it takes the most amount of steps within the given time. So we're going to use the quantity and time to calculate a rate at which the most amount of steps will occur within the given time. All right. How are we going to get that rate, right? So the trick here is using the biggest number in our input piles. So we're going to go for this and find the biggest number. We can do that by doing math.max and spreading in the array. That will give us the largest value here, and we can set that as our right. So this is binary search, right? We have a left, a right, and a middle, which will give us log of n operations. This is why we want to use binary search here. So we'll set the largest value to our right, we'll set 0 to our left, and we'll use all the numbers in between those two. All right. So at first, the rate is going to be the middle number. In this case, it's 5. And then we basically use that middle number and divide each pile by it. So 3 divided by 5, 6 divided by 5, 7 divided by 5, and 11 divided by 5. And we add those up. We add those up to get how much time it would take us at this rate. And then we compare our rate versus the rate that or I'm sorry, our total time against the time that the guard was gone for. And according to that, if we're less time than the guard is gone, then we put the minimum, like, so of this number, initially we set it to 11 because that's the worst case. But we compare our new middle rate against our old rate, which is this case, in this case, it's 5 against 11. Which one is smaller? 5 is, so we set that minimum bananas to eat per hour to 5, and then we want to look for a smaller value. So we're going to move this right to middle minus 1, and then middle will move to 2, and we'll keep looking for a smaller time. And vice versa, if our um, hour is too long, we're not going to move it like this. We're actually going to move this here. And basically that will help us get a smaller number. Time and space complexity are if n is the length or size of piles and h is the number of hours. So for time complexity, we're going to do the length times log of h, right? Because we're only going to we're only going to multiply um, this number against all the numbers in piles for log of h. All right, and same space complexity, we're only going to create space between this range for the log of 8 or h. All right, so let's step through the algorithm one step at a time. So the first step, we have left is 0, right is 11. And again, we set the minimum bananas to eat per hour to our worst case, which is 11. So now we're going to calculate middle eating rate, which is 0 plus 11 divided by 2, rounded down, that gives us 5. Then we calculate the middle hours. At first it's 0, but we're going to go through and divide every single one of our inputs by our mid eating rate. And that will give us 5. Here's the total arithmetic. Okay, so 5, that's in hours, right? That's hours. So we have to compare that to how many hours the guard is gone. The guard's gone for 8 hours, okay? So we can, yeah, we're good. So we can take the minimum between 11 and 5, which is 5, and then we just move our right pointer to 4, and that will look just like this. All right, so here we are now. We're going through the second time. Min is 0 still. Max is now 4, and we calculate, oh, we did update this, right? It changed from 11 to 5 here. And we're going to calculate the new middle, which is just 0 plus 4 divided by 2, which is 2. All right, and then now we're going to calculate the total amount of time it takes us. So we divide each one of our inputs piles divided by 2, the middle number. That gives us 15. Uh-oh, 15 is not smaller than 8 or equal to 8, so we move left. All right, so now we're moving left. So min eating rate is 3, max is 4. We're still at the minimum rate is still 5. We calculated our new middle. In this case, that's 3 plus 4 divided by 2, rounded down, is equal to 3. All right, and then we do our arithmetic with 3, and that gives us 9. Again, 9 is not smaller than 8, so we're going to move our left pointer again. We move our left pointer, and then now they're all lined up. 4, 4, 5 still, and our middle eating rate is going to be 4 plus 4 divided by 2, and that's 4, right? Middle is here. We do the arithmetic. We come out to 8. And look, 8 is equal to 8, so we're good. We can take the smaller number between our current middle rate and our old middle rate, which is 4, update it, and we go to our last step. Now we're going to have to move our right, just like we did here. We set it to middle minus 1. Now it's 3, but our while loop cannot execute because min eating rate is not less than or greater or equal to max rate. So we just stop and we return our minimum bananas to eat per hour, which is 4.